Example 4a, the height of an object moving vertically given by negative 16t squared plus 96t plus 112 with s in feet and t in seconds. Find part A, the object's velocity, excuse me guys, when t equals to 0. And part B, find the maximum height when it occurs. And C, when the position is 0, find its velocity. All right, so we are given position is negative 16t squared plus 96t plus 112, and it is measured in feet, and time is in seconds, okay? Part A says find the velocity when time is 0. So we want to find the derivative of position, which is negative 32t plus 96. And then plug in 0 because it's asking for time equals to 0. So if I plug in 0 for time, we are going to have 96 feet per second. So the velocity when t equals 0 is 96 feet per second. This means it's the speed, okay? Velocity is very similar to speed, except velocity has direction. Since this is positive, we know that this is going to the right. So velocity when we start out is 96 feet per second, okay? Then part B says, find its maximum height and when it happens, when it occurs. So B, maximum height, students, it's at the vertex. Well, vertex is when velocity must equal to 0 because that's when the horizontal tangent is. We already have the velocity, which is negative 32t plus 96. We are going to set equal to 0. Move 32 to the right, so that's going to be positive. Divide both sides by 32. T is going to be 96 over 32, which is going to be 3. Now that's the time. Look, it's looking for when it occurs and what is the maximum height. To find the maximum height, we have to plug it back in the S of 3. So S of 3 is negative 16, 3 squared plus 96 times 3 plus 112. With all of our basic math, it's gonna be 256 feet, okay? So the maximum height, of the object is 256 feet and it occurs at 3 seconds. All right, then we have to go and answer part C. Find its velocity when position is 0. All right, so we gotta go and position equation is negative 16t squared plus 96t plus 112. Now, student, position equaling to 0, meaning that when it starts or when it landed, right? So we are going to see if we can factor this out. Looks like I can take out a negative 16, okay? If that's the case, this is now positive, this is now negative 6t, this is now also negative. Then negative 16 equals to 0, that doesn't make sense, so I'm going to factor these out. This is t minus 7, t plus 1. So t equals 7 and t equals negative 1. Well, the negative 1 for time, that's not going to make sense. So the position is 0, meaning that this is now when it landed. All right, guys. So when it landed, let's check out the velocity because now we have to plug it back in. Velocity of 7. The velocity equation was, it was here. Okay, so negative 32 times negative 32 times 7 plus 96. So velocity when this object is landing is negative 128 feet per second. All right, so that makes sense because it went up. So let's talk about this really quickly. This right here is the velocity when it went up at time equals to 0, which explain why it was positive. It was positive 96. I'm sorry, positive 96. No, that's not the one. Sorry, this one up here. Velocity equals to 0. So when it went up, the velocity is positive because it was going upward of 96 feet per second. Now it was landing in 7 seconds, so that's why when the velocity is negative. So the velocity when the object was landing at t equals 7 seconds is negative 128 feet per second. Right? So again, velocity can be negative. Let's go to example 4b. The height of an object moving vertically is when it's given by s equals negative 12t squared plus 16t plus 72 with s in feet and t in seconds. So very similar. Find part A. I'm going to ask you guys to do that for me and then write out a complete sentence. So find part A. The object's velocity when t equals to 0. Please work that out. Let me know what the answer is. Show me all the work. Write a complete sentence. And then part B, similarly, I want you to work that out. So A, B, and then part C, find the velocity when the position again is at 0. And again, position at 0 is when it's landing, or if it could also when it goes up. Okay, but part A already asked when t equals to 0. So, well, sometimes you can start the object at time equals to 0. And that is not at 0. So right now it's at 72. So this object, it's at 72 feet when it starts. So when the position is at 0, you're not going to have a time equals to 0. All right, guys, so work that out. Write yourself a complete sentence, and then we'll check that later.